All right, folks, 5.3, we're going to talk about solving systems of equations by elimination. Elimination means we're going to eliminate or cancel the variable out. So we looked at graphing in part one, graphing the lines, figure out where they intersect, substitution by plugging in things, replacing things, and then now we're going to talk about elimination. So elimination is a situation we're going to use. We kind of covered this in our last section when things are not set up in a way to graph or in a way to substitute. So elimination is another step and tool we can use when things are set up properly. So here's what we're going to look for elimination. We're going to try and cancel out one of the variables, either x or y. All right. What we're going to look for is this. In order for things mathematically to eliminate essentially means we want them to result in 0. Okay. Now, I can do that multiple ways. I can maybe multiply by 0 or divide by 0, but in an equation, when you multiply and divide, you got to do that to everything. Another thing that could happen is if I, let's say, add, 2 and its opposite -2, well, two things that are opposites, those also cancel out to be 0. And that's what we're going to look for, is we're going to look for this thing right here. In order to eliminate things, we're going to look for one of our variables to be equal and opposite. So you'll notice here in this example, I have 2x and -2x. See how those are equal in value but opposite in signs. My y values, however, are not. I have 3y and 2y. Those are not equal, nor are they opposite. And then the numbers at the end I don't really care about. What I'm looking for are my variables. But what I have here is I have two equations, and my x values are equal and opposite. If that's the case, what I can do is I can solve this by elimination. To do this, what we're going to take is, once I identify these things as being equal and opposite, I'm going to take the two equations and add them together. Okay? And I'm literally going to add all the x's together, so the 2x and -2x. I'm going to add the y's together as well as the numbers together. And watch what happens. When I take 2x minus or plus -2x, what happens there is those would end up canceling each other out. They eliminate each other. The y's, however, 3y and 2y, would combine to give me 5y. And then in the end, 12 and 3 would end up combining to give me 13. So by eliminating them, what I'm left with is a simple equation that says 5y equals 15. Then I can solve for y by dividing both sides by 5, and I'll know that y is equal to 3. And once I know what y is, like we talked about in our last section, once we know what one of the things is, we can solve for the other one. Okay? So that's kind of the steps we're going to take. We're going to first take a look for equal and opposites. We are then going to add those equations together to eliminate one of them. We're going to talk about a case in what if they're not equal and opposite. We'll talk about that. If so, what we'll talk about number 2 is you're going to use the process of multiplying to make them equal and opposite. And then you're going to solve by eliminating and then using your answer to substitute and solve for the others. Let's go through our examples. So here I have 3x and 3x plus 2y equals 4, and 3x minus 2y equals -4. So I'm going to solve this by elimination. What I'm looking for is equal and opposites. Hopefully you can see the y's. I have 2y and -2y. Those are equal and opposite. The x's, however, are just equal. They're not opposites. So I can eliminate the y's. To do that, what I'm going to do is take the equations and add them together. What's going to happen is the 3x's would combine to give me 6x. The y's are going to cancel because they're equal and opposite. And then my two numbers at the end, 4 and -4, well, those actually will also cancel and leave me with 0. Now, this does not mean that there's no solution, but when I divide both sides by 6, what I get is x equals 0. So I now know what x is. All right, so notice with elimination, once they're equal and opposite, it's actually pretty easy. Put the equations together, boom, I can solve my equation. Now, like you've seen in graphing and substitution, there's some parts that do take a little bit more work. Graphing, if everything was set up, it was kind of actually easy. Substitution, once I got the first answer, it was easy to plug it back in and get my second answer. Now here, it's easier to get my first answer, but it's going to take a little extra work to find the second. So to find the second, when I find my y value, here's what I need to do. I need to take 0. I now know what x is. So if I know what x is, I can plug 0 into any of these two equations. That'll allow me then to solve for y. So that's what I'm going to do. I'm going to take 0 and I can plug it into any of the equations. So I'm going to plug it into the first one. 3x plus 2y equals 4. And what I'm going to do is I'm going to take that x value of 0 and I'm going to plug it in where x goes. So like we've talked about, 3x means 3 times whatever x is, which is 0, plus 2y equals 4. That means I can take this equation and solve for y. So 3 times 0, that'll end up canceling each other out, give me 0. What I'm left with is 2y equals 4. Divide both sides by 2, and I'll get y equals 2. Shebang shabop, there's my answer. Solving by elimination. What I would get here is I would get my point, my x value of 0, my y value of 2. And it all goes back again to graphing, that would be the intersection point of those two lines, 0, comma 2. So again, looking for equal and opposite, adding them together to cause them to cancel. All right, next example, I have negative 2x plus 3y equals 4, 2x minus y equals negative 8. So if I add these together, I should notice that the x's right away are equal and opposite, negative 2 and positive 2. The y values are not, 3 and negative 3. So to add these together, the x's would end up canceling each other out. The y values, 3y and negative 1y, would end up giving me 2y. And then 4 and negative 8, add those together, would end up giving me negative 4. So if I were to solve for y by dividing both sides by 2, I'll get y equals negative 2. So again, real easy to solve this one for the first variable by just eliminating. Now to find the second variable, we're going to take this value of y, negative 2, and we're going to plug it in to one of these two equations. I like to be consistent. I like to always plug it into the first equation, even though it really doesn't matter. Okay, so I'm going to take it and plug it in for y in my second equation. So that's where negative 2 is going to go. So I'll have 2x plus 3y. Now 3y means multiply 3 times negative 2, and that should equal 4. So again, I plug negative 2 in where y goes. Now I got to simplify. So I have 2x. 3 times negative 2 would give me negative 6 is going to equal 4. And now I can solve using my inverses by adding 6 to both sides, getting 2x equals 10. And lastly, dividing both sides by 2 and getting x equals 5. And there would be my answer. So again, as a point, combining these two things together, I would have a value of 5 for my x, negative 2 as my y, and there's my final answer. Okay, and again, we're the point where those two lines cross. All right, these next two examples, you'll notice that the x and the y, I don't have equals and opposite. I have negative 10 and negative 5, not equal, not opposite. I have 3 and negative 6, not equal, but opposites. And again, I have the numbers. So what do we do in a case when they're not equal and opposite? So what I'm going to try and do is I'm going to try and make them equal and opposite. To do that, I'm just going to use a simple property of all equations, and it's the multiplication property. I could use division, but I'm using multiplying because it's a lot easier. If I multiply something in an equation, I have to multiply everything to make sure it stays the same. So what I can do is I can take this entire top equation and I'm going to multiply it by 2. I'm going to double everything in the equation. Now watch what happens. Negative 10x would turn into negative 20x. Positive 3y would turn into positive 6y. And then 1 would turn into 2. I doubled everything. Now, I'm not going to change the second equation, but watch what happens. When I look at the second equation now, well, wait a second, Big Daddy. Oh, now notice when I doubled the first equation, now notice how my y values are equal and opposite. Nice. So by just multiplying by that number 2, I can make them equal and opposite. Which now when I add them together, I can eliminate them shebang shabop, and I get negative 25x equals 25. And by solving for x, I'd get negative 1. So there's my x value. That's nice. And now once I know my x value, I can go back and plug this in. Now when I plug it negative 1 in, I can plug it in anywhere I want. I can plug it in here, 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 here. So let me just pick one. Let me just pick the second equation. So I have negative 5x minus 6y equals 23. So I'm going to plug negative 1 in here for x. So I'll do negative 5, and then instead of x, I'll do times negative 1, and then minus 6y equals 23. Simplifying this, negative 5 times negative 1 would give me positive 5, minus 6y equals 23. If I then subtract 5 from both sides, I'll get negative 6y equals 18. And then lastly, dividing both sides by -6, I'll get y equals -3. And boom, there's my y value for my final answer of a point, or as a point of -1, -3. Now, the main detail here again was multiplying at the start, multiplying one of my equations by a number to make them equal and opposite. All right, now, same thing here. I have 3x, 2y equals -2. Here, -6x, -5y equals 2. So what I want to try and do is make them equal and opposite. So you'll see, kind of like the last example, I have 3 and 6. Now, I'm going to just, on purpose, show you guys another way to do it. I'm going to eliminate the y's. Why? Because I want to. So I can multiply one equation to make them equal. I can also multiply both equations. So let's say that I had 2 and -5 and I want them to eliminate. 2 does not go into 5. So if I wanted to make them eliminate, what I can do is change both equations. What is the number that both 2 and 5 go into? Well, they both go into number 10. So if I take the first equation and multiply it by 5, here's what I'd get. I'd get 15x, almost said 3. I'd get plus 10y, and then it would equal -10. The second equation then, I'm not going to multiply that by 5, but I want that y to become a 10. I'm going to multiply it by 2. That would give me -12x. I'm going to double everything, minus 10y, and that's going to equal then 4. So I can multiply both equations as well, not just one. And again, once I add these together, you'll notice that the y's would cancel out, and it would leave me here with 3x, 15 and -12 is going to equal -10, and 4 would give me -6. And therefore, x is going to equal -2. So there's my x value. So again, I multiplied both equations. I didn't have to do that. I could have eliminated the x right away, but I wanted to multiply both just for the fun of it. But now that I know what x is, now I can solve for y by plugging it in. So I'm going to choose an equation. I'll choose the first one, 3x plus 2y equals -2. I'm going to take that value of x and plug it in where x goes. So it'd be 3 times -2 plus 2y equals -2. Then simplifying 3 and -2 would give me -6 plus 2y equals -2. I'm going to do my inverse operations. I'm going to add 6 to both sides, and I'd get 2x equals 4. Then lastly, divide both sides by 2, and I'll get y equals 2. And there is my answer. Lock her in. Y equals 2. My final answer is going to be, as a point, -2, 2. What ballerinas wear? Okay? That's so much fun. Solving by elimination, making them cancel. Another one of these dreaded word problems. Now we have large vans, small vans. We have business with 2 locations, by 7 large delivery vans and 5 small delivery vans. It says location A receives 5 large vans and 2 small vans for a cost of $2,000 or $235,000. Location B receives 2 large vans and 3 small vans for a cost of $160,000. I want to know what's the cost of each van. So notice in these 2 sentences, we're going to get our 2 equations. 5 large vans, 2 small for that total. 2 large, 3 small for that total. So if I were to write these out, I have 5 large vans. I'll say the large vans is x, small van is y. So 5x plus 2y equals 235,000. Why you give me such big numbers? Because I want to. Then you have 2 large vans and 3 small vans for a total of 160,000. Now what I'm going to do is I'm going to solve this. This would be a case in probably solving by elimination. Now, kind of like my last problem, there's a purpose of why I did it that weird way. Is because I want to get one of these to eliminate. I have 5x and 2x, not equal, not opposite. 2 and 3, not equal, not opposite. So I have to make them equal and opposite. Now here's the issue. If I look at, for example, the 2x, 2 does not go evenly into 5. Ugh. Same thing with the y's, 2 and 3. Well, 2 does not go evenly into 3. Ugh. Now, what I'm going to do then in that case is I got to make them equal and opposite by multiplying both equations by a number. So what do we want to eliminate, x or y? I feel like eliminating x in this case. So I have 5 and 2. So maybe let's take 5 and 2 and turn them into a common number. Maybe like 10? Sure. Okay, that sounds good. So I'm going to take the 5 and multiply it by 2, and I'm going to take the 2 and multiply it by 5, right? That's going to give me 10x and 10x. Now here's the issue though. They're both positive. Everything in this equation is positive. So how the heck do I make something opposite? Oh, wait a second. Maybe I multiply by a negative. Now I could do -2 or -5. Just for funsies, I'll do -2. Now what that means is I'm going to multiply everything in this top equation by -2. I'll write this below. So I would have here -10x, -4y equals 470,000. When that would be a -2. I'm sorry about that. Big number. I know, big number. Okay. So that's what I got from the first equation. Now, my second equation in blue, I'm going to multiply just 5. So 5 times 2 would give me, oopsies, would give me 10x. And then I'm going to multiply the 5 to the 3 as well as the 160,000. So I would get then plus 15y equals 800,000. Wonderful. All right, now I have my two equations set up so that the x values are going to cancel out. So when I add these folks together, -10x and 10x would cancel. And what's going to happen then is everything else will work out pretty. So -4y and 15y would give me 11y. And then those two big numbers added together would give me 330,000. Nice. Then solving for y, I'm going to divide both sides by 11, and I'll get y equals 30,000. Fantastic. $30,000 for, in that case, y would be the small van. Okay. So $30,000 for the small van. That makes sense. Now our goal is to figure out what's the cost of the large van. So that would be x. So what I'm going to do is take this value of y and plug it into one of my equations. I'm going to plug it in the very first one. So here I have 5x plus 2y equals 235,000. I'm going to take this value of y, $30,000, and plug it in where y goes. Here's what I'd get. Oopsies. I'd get 5x plus 2 times 30,000 equals 235,000, bruh. Multiplying 2 and 30,000, I'm going to get 5x plus 60,000. It's going to equal 235,000. Running out of some real estate here. I'm then going to subtract 60,000 from both sides. That's going to cancel here.